the search for new worlds is no longer in our hands? What if a different kind of intelligence is now scanning the cosmos 1,000,000 times faster than we ever could? An intelligence that's about to show us things we're not ready to see. For centuries, we've looked to the stars and asked the same lonely question: are we alone? Well, the answer might not come from a human voice anymore. It might just come from the hum of a machine that's becoming a better scientist than we are. And that might be the most profound and terrifying discovery of all. For as long as we've had eyes, we've used them to chart the heavens. We went from just looking up to crude telescopes and then to incredible orbital observatories like Hubble and the James Webb Space Telescope. With every leap, the universe came into sharper focus. But that clarity brought a new, overwhelming problem, a problem of sheer scale. Modern telescopes aren't just taking pictures, they're drinking from a cosmic fire hose. Every single day they pour down an avalanche of data so huge it's hard to wrap your head around. Hidden in this digital flood are the faint whispers of other worlds. The tiny dip in a star's light as a planet passes in front of it, the slight wobble of a sun pulled by an unseen companion. These are the clues that lead to discovery, and we've been getting pretty good at it. As of late 2025, NASA's official catalog has blown past 6,000 confirmed exoplanets. Just a few years ago, that number was 5,000, which shows you how fast we're finding them. But here's the unsettling part. For every planet we've confirmed, there's a backlog of thousands of candidate planets still waiting to be analyzed. And that's just the data we've managed to look at. How many more are buried in the noise, missed by the tired eyes of human astronomers? We've hit a wall, not a technology wall, but a human one. Our greatest instruments are now showing us more of the universe than our brains can possibly process. We're standing on the shore of a cosmic ocean trying to count the grains of sand. Discoveries that could redefine our place in the cosmos are probably just sitting on a server somewhere, completely unnoticed. We built the tools to find new worlds, only to realize we had become the bottleneck. Confirming a planet has always been a slow, careful, almost artisanal process. An astronomer spots a potential signal, a transit, and then has to wait for it to happen again and again. They check it against other observations, rule out cosmic false alarms, and then send their work off to be double-checked by other experts. It's a system built on rigor, but it is profoundly, agonizingly slow. For every big, easy-to-spot gas giant, there could be dozens of smaller, rockier worlds hidden in the data, worlds a lot more like our own. Finding these is way harder. Their signals are fainter, much easier to mistake for static. The work is so demanding that in 30 years of searching, we've only managed to find a handful of truly Earth-like candidates. This isn't just some academic thought experiment. It feels like a race against ourselves. The universe has been around for 13.8 billion years. It'll be here long after we're gone, but the window for our civilization to find these answers feels a lot shorter. Are we stuck searching for our cosmic neighbors at a snail's pace while the evidence we so desperately need just piles up, unseen? What if the next great discovery isn't waiting for a bigger telescope but a faster mind? What if we could analyze all that data not at the speed of a human, but at the speed of thought itself? This is the question that has led scientists to a radical new solution, one that takes the search out of our hands and gives it to a completely new form of intelligence. Meet the new astronomer. It doesn't have a body. It lives inside a computer, and it's about to revolutionize our hunt for planets forever. At the University of Bern in Switzerland, researchers have developed a groundbreaking artificial intelligence that is completely changing the game. This AI is built on what's called a transformer architecture, the same kind of technology that powers advanced language models like ChatGPT. But instead of being trained on Wikipedia and the internet, it was trained on the fundamental laws of the universe. Scientists fed it tens of thousands of complex simulations of how planetary systems form and evolve. It didn't just memorize the data, it learned the underlying physics. It learned the story of how a solar system is born, and now it can predict the ending. Here's how it works. And it's both brilliant and a little unnerving. By analyzing just one known planet in a distant star system, The AI can predict the architecture of the entire system. It can guess the location, size, and presence of other planets that are still hiding from us. It's like being able to reconstruct an entire dinosaur from a single fossilized bone. And it does this with breathtaking speed, a simulation of planetary formation that would take a supercomputer days or even weeks to run. This AI can do in seconds. That's 1,000,000 times faster than our best traditional methods. When they tested it, the planetary systems it predicted were so accurate they were practically indistinguishable from the ones created by years of painstaking simulation. It has, in effect, become a new kind of scientist, one that can do 1,000,000 years of human work before we've finished our morning coffee. So, this is the mind-blowing discovery. It's not one single planet, it's not an alien signal, it's the discovery of a method so powerful it completely redefines the speed of exploration. And this is where the idea gets a bit terrifying. Not monster in the dark terrifying, but the kind of terrifying that comes with a truly profound shift in how we see the world. The rate of discovery is about to accelerate beyond our ability to emotionally and philosophically process it. For decades, finding a new exoplanet was a headline. Soon we could be discovering thousands a day. This AI allows astronomers to point their telescopes with surgical precision, telling them exactly where to look to find the worlds that matter most. It puts the hunt for the ultimate prize on fast forward, finding a true Earth twin, a rocky planet in the habitable zone of a sun-like star. But what happens when we find not one but 1,000 of them? What happens when we have a list of 10,000 candidates for life? The problem shifts from, can we find it, to, what do we do when we find everything? We are speeding toward the discovery of worlds we aren't prepared for, not because they harbor hostile aliens, but because their existence in such huge numbers will force a monumental shift in human consciousness. Finding one Earth-like planet is a miracle. Finding thousands makes life elsewhere a statistical near certainty. It makes our own specialness feel, well, less special. And it raises the stakes for the next generation of explorers who will be handed a list of destinations too long to ignore. If this new AI is the software, the celestial brain, then what's the hardware? What body will this new intelligence use? The answer, it turns out, is not on Earth. Google recently announced a moonshot initiative called Project Suncatcher. The plan is as ambitious as it is brilliant, to scale up machine learning computation in space itself. One of the biggest problems with massive AI models on Earth is that they use an astonishing amount of power and resources. Project Suncatcher bypasses that problem by going straight to the source. The vision is to launch constellations of compact solar-powered satellites, each one packed with Google's advanced AI chips, called Tensor Processing Units, or TPUs. Linked together by lasers, these satellites would form a thinking network in orbit, powered by the clean, uninterrupted energy of the sun. This isn't just a wild idea on a whiteboard. Google has already stated there are no show-stopping physical or economic barriers, and they're partnering with the company Planet to launch the first 2 prototype satellites by early 2027 to test it all out. Think about what that means. You take the planet-finding AI from the University of Bern and give it a home in space, powered by the sun, with a direct, unfiltered view of the cosmos. You create a permanent discovery engine that never sleeps, never gets tired, and learns more with every passing second. This is the next logical step in our evolution as explorers. We're not just building tools to look at the universe. We're building a mind to understand it for us, and we're putting that mind in the sky. This all brings us back to that slightly uncomfortable truth. When our creation becomes a better scientist than we are, what does that mean for us? It's a question researchers are already tackling head-on. In fact, an astronomer at the University of Arizona has developed a clever way to make AI systems more trustworthy by letting them tell us when they're not sure about something. By applying a technique called Bayesian sampling, this new method allows an AI to essentially know what it doesn't know and flag its own uncertain conclusions for a human to review. This is crucial. It shows the goal isn't to replace human scientists, but to create an incredible partnership. The AI becomes an impossibly fast and brilliant research assistant, sifting through the cosmos and bringing us the interesting stuff that requires our uniquely human wisdom, curiosity, and judgment. Our role is changing. We are no longer the ones staring at flickering data, hunting for a one-pixel dip in brightness. We're becoming the architects of the minds that do the hunting for us. We're moving from being calculators to being curators, from data miners to philosophers. The AI can find a planet, but it can't feel the awe of that discovery. It can label a world as habitable, but it can't ponder the meaning of the life that might be there. That's our job now. The breakthroughs we've talked about today are just the start of a completely new chapter in our story. The line between human and artificial intelligence is blurring, and the frontier of space is where this team-up is producing its most amazing results. If you want to stay on the front lines of how technology is reshaping our future, make sure to subscribe and let me know in the comments, what do you think this new power will find first, an Earth twin or something we can't even imagine yet? So, we return to where we started. The search for new worlds is passing out of purely human hands. An intelligence a million times faster than ours is now scanning the heavens. But it's not a hostile takeover. It's a handover, a necessary step in our own evolution. For centuries, we've been limited by our own biology, by the speed of our neurons and the short years of our lifespan. We've finally built an extension of our own minds, one that's free from those constraints. The AI's discoveries aren't terrifying because they're alien. They're terrifying because they're a reflection of our own limitless potential and the sheer scale of a universe we have only just begun to comprehend. The real mind-blowing discovery isn't just one planet, it's our new place in the cosmos. We are no longer just the lonely species looking up at the stars. We're the species that built an intelligence to finally help us understand what we're looking at, and the universe will never look the same again.